Good morning, my YouTube viewers. It is Crystal here. I'm here this morning because I wanted to give you another code review. This code review that I'm going to give you is going to be on the Perceptron, which is one of the earliest neural networks in machine learning, and they've actually been working on the Perceptron since the 1950s. So the Perceptron is actually about close to 70 years old. That's how long scientists and machine learning technicians have been working on neural networks. Although TensorFlow just came out in 2014, and sklearn, it has a neural network, MLP and MLPC, those came out when sklearn came out in the early part of this century or several years ago. But truthfully, scientists have been working on neural networks for close to 70 years, and the Perceptron is the earliest one. It is the most basic one, and it's what we're going to be covering in this code review. And we're going to use the iris dataset for it, but the Perceptron deals with binary classification, and because of that we had to make the iris dataset binary, because I tried to use the Perceptron just using the 3 classes, and it didn't work with the 3 classes because the Perceptron is for binary classifications. So what I had to do is I had to take the one of the species and put it in with another species, so we only would have 2 species to work with and the Perceptron would work. So I did that for this exercise only, and we know that iris has 3 species in the iris dataset, not 2, but just so I can demonstrate how the Perceptron works, I made it binary instead of trinary. So before we do that, let's just come over here. Let's look at the Perceptron. So this is your Perceptron here. You've got your weights go into the net input function, and they go into an activation function. But we can come over here and look at images. And so this is what I've used. So you've got your constant, which is 1, and then you've got your inputs. You've got your 3 inputs, and you've got your weights, and then you've got a weighted sum, so it sums the weighted sum, and then it goes through a step function, and a step function is similar to a sigmoid function, and then it's out, and then you have your output. And the reason why it has to be binary is because a step function can be either a 1 or a 0, and the step function is similar to a binary, a sigmoid function. So now that you know what the Perceptron looks like schematically, what we'll do is we'll go ahead and do the code review. So I've written this program in Google Colab, which is Google's free online Jupyter notebook, and Google Colab is a great platform to use, with the exception of the fact that it does not have a very good undo function. So when you're working with Google Colab, you need to be very careful that you don't accidentally delete or overwrite valuable code. So after we created our program, what we want to do is we want to import the libraries. So we're going to import NumPy as NP, and what that does is that creates NumPy arrays and performs numerical computations. We're going to import Pandas as PD, and what that does is that creates series and data frames and it data processes. We're going to import matplotlib.pyplot as PLT, which is a visualization. It visualizes your data. We're going to import Seaborn as SNS, so it also visualizes the data, but it does it statistically. And then we're going to import sklearn, which is your machine learning library. So after we have imported the libraries, what we're going to do is we're going to use Seaborn's iris dataset, and the reason why we're going to use Seaborn's iris dataset is because it presents it in a data frame, and it also labels the different columns, whereas in sklearn it doesn't label the columns, it just puts it in the format of a array. And so it's a little bit more difficult to work with because it doesn't label the columns. So we've got iris equals sns.load dataset iris, and you can see the iris. You can see you've got the columns are sepal length, sepal width, petal length, petal width, and the species is your target. And you have three species. You got Setosa, and you got versicolor, and you got virginica. And you have 150 rows by 5 columns. So now what we're going to do is we're going to do a scatter plot of the species. So sns.facetGrid, iris is your data set, U is species, that's your target, height equals 6, map and plt scatter, sepal length and sepal width add length. So you're only going to be using the sepal length and the sepal width. You're not going to be, the sepal length and petal length. You're not going to be using the sepal width and the petal width. And you're going to add a legend. So you can see that these are the three species you have in the iris dataset. And so what we're going to do is we're going to split the iris dataset. So y equals iris.iblock, and then the colon means all of the rows, and -1 means it's the last column. X equals iris.iblock, the colon means it's all of the rows, and 0 to 3 means it's columns 0, 1, 2, 3. And then, so we definitely made a mistake here. Should be 0 to 4 because that should be 4. So I definitely made a mistake here. So it's a good thing that I'm doing this code review so I can see the mistake that I made. And now what we're going to do is we have to make this a binary classification. And when we make this a binary classification, what we do is we create a variable called new y, which is an empty list, for I in range list y. If yi equals virginica, then you're going to make yi equals versicolor, and you get a new y dot append yi, and new y equals PD's series new y. So now what we're going to do is we're going to use sklearn's train test split to split the data set up into training and validation sets. So x train, x val, y train, y val equals train test split, x, new y, test size equals 0.2, random state equals 42, shuffle equals true, and so your x train is 120 by 4, your x val is 30 by 4, your y train is 120, and your y val is 30. So now what we're going to do is we're going to define our model, which is the Perceptron. And as I said before, the Perceptron is a binary classifier, so you can only have one of two classes. So model equals Perceptron, fit x train, y train, print model.score, x train, y train, and you get 100%. And now we're going to predict on the validation data. ypred equals model.pred xval, and then here's your ypred. So it's going to be either versicolor or Setosa. We check the accuracy score, and it's 100% when you make a prediction on the validation data. We check the confusion matrix. You have 10 ones and 10 zeros and 20 ones. We check the model coefficient, so you can see the model coefficient on each of the columns, and then you check the model intercept, which is -1. So that's it for this demonstration of the Perceptron. And as I said before, the Perceptron is like the earliest neural network. It's about 70 years old. It only works on binary classification data, which is why we had to convert the iris dataset to a binary instead of a triple. But that's how it works. So that's a good way if you want to practice on the Perceptron. You can probably try to find a data set that's a binary and see how it works. So I'm going to go ahead and conclude this code review. I hope you got a lot out of it. You know a little bit about the Perceptron now, a little bit about how to use the Perceptron, and you can only use the Perceptron with the binary classification, because I tried to use it using all 3 classes and it simply didn't work. So it doesn't work if you try to use it on more than 2 classes. So thank you so much for watching my video. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you to my subscribers for supporting my channel. I look forward to making more code reviews for you in the future.